Welcome to Flink Forward Asia 2024.
Kita semangat pagi. Mereka doang kayaknya semangat banget. But it's okay. Anyway, kita siap untuk masuk ke sesi berikutnya ya. Kali ini kita akan membahas mengenai streaming data contract with Debezium and Apache Flink. So now I have Mr. Gunnar Morley. Dia adalah software engineer di Debezium. So give applause to Mr. Gunnar Morley. The stage is yours.
All right, hello everybody, welcome to this talk. I'm very happy to be here, very happy to see all of you here. And I want to talk about streaming data contracts with Debezium and Apache Flink. So let me ask first of all, so who has heard about Debezium? Yeah, okay, that's like maybe a third of you. Who's using Debezium in production? Okay, very good, excellent. Who has heard about Flink? Half of you. Who's using Flink? Okay, very good. So like one third, maybe that's good. All right. So can we go to the slides? There you go. Perfect. All right. So now, I've been working on Debezium and change data capture, and I will explain what all this is and why I want to use it for quite a while. And one of the concerns people sometimes have, if we do change data capture, does it mean we break the isolation of our data model? And when people bring up this concern, of course, is something I care about. So I thought, okay, let me actually go and explore this topic, and also let's talk about it. So that's the idea for this. And to set the scene a little bit for what you can expect, I want to talk. I want to give you an introduction of what is Debezium, what is Flink, why do we want to use them. Then we would like to dive a little bit into this aspect. So does CDC change data capture, break and isolation? And I want to talk about a solution to it, which would be data contracts. And I also want to talk about an aspect which comes up pretty much every Q&A, which is how can we actually go and change and evolve our data streams. A few words about myself. I work as a software engineer at a company called Decodable. What we do there is we build a fully managed platform for stream processing based on Apache Flink. So essentially it's Flink as a service, and you can use it for writing Flink jobs if you have also basic plain data movement use cases, taking data from Postgres to Snowflake or to OpenSearch. This is something which we could help you with. All right, so let's talk a little bit about what is CDC, change data capture. And essentially it's like the observer pattern for your data. So what that means is, whenever there's a change in your database, something like MySQL, Postgres, or Oracle, whenever there's a change, you would like to be notified about that change. You would like to be able to react to that change. And this is exactly what log-based CDC does. Because all the databases, what they have, it's called the transaction log. And this is essentially the source of truth of a database. And now whenever a transaction comes in, so let's say a customer record gets inserted, something gets updated, or something gets deleted, the database will append this event to the transaction log. And the database uses the transaction log for replication purposes, so to take the data and replicate it to another node to the database cluster, or for the purposes of failover recovery. And now what Debezium, as one implementation of log-based change data capture does is it taps into the transaction log, and whenever the transaction appends the event to the log, it will then capture that event and propagate it to the outside world. So typically using Apache Kafka, or maybe tools like Amazon Kinesis or Google Cloud Parser, Apache Parser. So we would have those messaging infrastructures in the middle to propagate those events, and so we then can have our consumers and subscribe to those change events. So that's it on a high level, from a high level perspective. Now, why is this so interesting to be able to react to those data changes? So, whenever a customer gets inserted, purchase order gets updated, something gets deleted, you can react to that event with a very low latency. It could be like milliseconds. So, for instance, in case of the Debezium Postgres connector, you will have events within a couple of two-digit milliseconds, like 50 milliseconds or less. Data could be. And now, this enables all kinds of interesting use cases. So you could use those change events just for replication purposes. So you could use them to just take your data, from Postgres into your Snowflake data warehouse or your search index, such as Open Search or Elasticsearch. So just replication. But you also could use those change events, for instance, to build like an order block. So maybe this is a requirement you have in your application. You need to keep the history of all the state transitions of your data. So whenever like a purchase order gets updated, it changes its state from it was entered to fulfilled or shipped or verified or whatever it is. We would like to keep track of the history of those state transitions. And now if you have these data change events, let's say a Kafka topic, or maybe you put them into, let's say, Apache Iceberg, but that's sort of on and on, right? There's many other use cases, like caching. Very often we need to do that, right? So we would like to maybe take our data, denormalize it a little bit, and then keep some view of the data in the cache close by to our users. And having this change event string, this enables us to implement this sort of caching response. Many others more. I wrote a blog post. You can go to this QR code where you can read and learn about those CSC use cases. But that's it on a high level. Now let's take a little bit a closer look into those actual change events. So I mentioned Debezium and CSC. It gives you a change event for each insert, update, delete. And this is how they look like. So essentially, they represent the state of your table, right? So let's say you have this customers table with columns, first name, last name, email, and so on. The change event, in this case, describing an update, well, it would have this before and this after state, and then you have the actual fields which represent your data columns. And now this touches a little bit already on this concern about breaking encapsulation, right? Because, well, our field names from our table, they also show up as or the column names from our table, they show up as the names of the fields in those change events. And now let's say we were to change the name of the column, well, it would also be the change in those data change events, and this might break our consumers, right? So that's part of the concern. But this is essentially what those change events would look like. Okay, so people use CDC, and it's used a lot. I even saw it like in the keynote this morning, also here. So a very diverse community of Debezium users. And well, if people use those tools in production, they realize maybe also those potential concerns, right? That there's those two blog posts, just to give you one or two examples, where Chris and Yaroslav, they did a great job of describing this, is this a concern or what are their thoughts, right? So again, definitely recommend to check out those blog posts. And this is really what, nerds like me to do this talk. So let's touch a little bit on those concerns. And the first one, see it here, and I mentioned it already, so our internal data model, it becomes the API of our application, right? So the names of our columns, they become a user-facing part, also the types. So let's say we have maybe some weird representation of temporal data types, and it's really awkward to expose it to our consumers. This could be a problem. Sometimes when we use some sort of a legacy database or legacy schema, we have very awkward column names. And do we really want to expose those column names to our data consumers? So that's a concern. Next one. Well, there's the question around the granularity of events. So those change events, change event streams, by default, they will correspond to one-to-one to the tables in your data model. Now this means, let's say you have maybe a concept that like a purchase order in your application. And now this would be persisted typically in multiple tables, right? So you would have one table with purchase order headers and then another table with the order lines. And you would have a one-to-n relationship between those two tables. And now you would get by default change events for purchase orders and then also change events for order lines. But maybe you would rather want to get change events which describe the entirety of a purchase order. So, like the result of this one-to-n join. So this granularity question, it's another potential concern. Next up, well, what if we do changes? So I mentioned we could rename columns, they could break potentially our consumers, or if we were to change the type or remove a column. Doing all those things, and we want to have the liberty to do those to our data model. But what does it then mean for the consumers of those changes? Finally, there's also a question to be asked about the amount of data we expose. So again, those change events, they represent the entire width of your tables, so all the columns and also all the rows. And maybe you want to just expose a subset of your data to your data consumers. Again, this is something to reason about. Well, it sounds all pretty terrible, right? Well, no, not, because the question is, do we really have a problem? And now I think it depends a lot on how we are going to use those events. I think it makes sense to think about it from a perspective, do we cross, for instance, the boundaries of organizational units? So let's say you're using those change events to update a search index for your application. And this search index, maybe it's an OpenSearch or Elasticsearch, and this search index, it's maintained and owned by the same team which also works on this application, which writes to this database. Then I would say, well, we don't really have a problem because we actually want that the data in the search index really reflects what we have in our database. And it's the same people who work on the application, who work on the database schema, who work on the search index, so they don't have any communication issues, right? And I would say it's fine. Whereas maybe we have a use case where we take those data change events, and then the consumers are like people. Maybe we don't even know them. Maybe it's like the guys working on a data warehouse, we never talk to them, they sit at the end of the hallway. Now if we do suddenly data schema changes, they might be upset, right? And in this situation we would have a problem. So I think it depends on use case. Now, let's explore a little bit, what we can do if it is a problem. And this is where this notion of data contracts comes in. So the idea there as well, instead of just tapping into the transaction log of our database and then kind of as an afterthought publishing those change events of our internal data model to the outside world, let's make this a bit more explicit and let's create a consciously designed contract which defines the data and the events which we send out. Now, if I say contract, of course it's not something legally binding, but it's the idea, to make it explicit, and it could describe, of course, the schema of the data, but then also the semantics of the schema. So, I don't know, maybe you have a numeric value, it's like a long timestamp, and people need to know, okay, this log actually is timestamp. Or maybe you need to describe, the units of measurements. So you need to define what are the semantics of the data. There could be things that in a contract like SLAs, or maybe like what's the rate of those events which you can expect. What is maybe examples, how could examples be different? So all those things could be, part of such data contract, data quality. The thing is, well, you want to formalize it, so how you do it, I mean, this is up to you, right? So it could be like a wiki page, it could be a more machine-readable description, but the idea really is to make the semantics, structure, and everything of your data that's like explicit, consciously designed, and documented so consumers can refer to that. So this is, the purpose of all the document already tagged, and essentially you want to create, you could call it like a data product, right? It's like this consciously designed stream of change events with a well-defined structure, not so much making an afterthought of just like randomly extracting events out of your database. How you can do it, or how you want to do it, well, there's different ways, different tools. Definitely check out this platform or website, datacontract.com. This gives, or defines like a YAML-based approach for doing this, so it's machine-readable, and you could then use, for instance, those data contracts, put it into some sort of repository, and your consumers could refer to them. Okay. So now the following, I want to focus in particular on the schema part of that, because of data changes and data contracts, because that's what we care most about. And I want to talk about two solutions, the outbox pattern and stream processing. First, about the outbox pattern. So the idea there as well, instead of extracting those actual raw table level events, like purchase orders, order lines, and so on. We will have another table, which we call the outbox table. And now our application, when it writes to the database, as part of the transactions, it not only updates and modifies those actual business tables, it also does an insert into this outbox table. So that's like the channel where we write our messages into. And now we would use Debezium or any other log-based CDC tool to only capture the inserts into this outbox table. And it would only ever be inserts because one of those events, they should be immutable, right? So once you have written an event like, I don't know, this purchase order was placed, you don't want to modify this event after the fact. So we do those two things, the update to our business model and the insertion of the outbox event in a single transaction. So this ensures atomicity. And then we would use Debezium to capture the change events from this outbox table. And now we have addressed this concern, right? Because we have decoupled our internal table model with our customers table, purchase orders, all lines, and so on. And it's independent from the schema which we use in this outbox message table. So we could then be very explicit. We could, differentiate. So we could have different names, different field types, and so on. Maybe just a subset, and we would evolve it with backwards compatibility, of course, in mind. So that would be one way. Of course, this requires you to actually modify your application, right? So you need to change your application so that it does those inserts into the outbox state. I just recently, like a couple of weeks back, I wrote a blog post about it, so you can go to this QR code, read it. It describes how you can implement the outbox better, alternatives, pros and cons. So definitely, I recommend to check this out. So that's the outbox better. But now, we being a Flink forward, I want to talk about another approach, which is stream processing. And there, the idea as well, we actually take those table-level change stream feeds, and then we use a tool like Flink for converting those raw event streams into, let's say, a higher level stream, which then is shown to our consumers. Now, I realize, there could be like an entire talk about Flink, and I also understand, not everybody may be super familiar with Flink. But just briefly, what we have there in Flink is essentially different layers, different building blocks. So at the bottom, we have things like, primitives which model events, event time, which model things like late arrival of events, and so on. And then on top of those building blocks, there's different layers of APIs. And those APIs, they essentially differ in terms of the flexibility in what you can do, versus, I would say, like the ease of use and how accessible those APIs are. So there's something like the DataScript API, which is a Java-based API, and you can do everything, but you also have to be a Java developer. And then on top of that, we have like things like the Table API, which gives you a relational representation of the data, and on top there's the Flink SQL API. And now, well, this is less flexible, right? So you cannot do certain things in SQL which you could use with a Java-based API. Let's say you want to invoke some sort of external web service to enrich your data. This is not something we should do with SQL. But then for many data transformations and enjoying your data, SQL is pretty useful, I would say. And there's just so many more people who know about Flink SQL, who can use it, right? This is exactly the tool which you want to use for our data projects, or which you can use for. So how would that look like, using Flink SQL? Well, let's assume our example is this again. So I have this customers table on the left-hand side, and you see, its schema, it has like oddities like F name and L name. Maybe those are like legacy column names, we want to change them. We don't want to expose them to our consumers. There's this status int, which describes like the status of a customer. So maybe we want to expose this rather as some sort of enum-based thing. There's this timestamp. Maybe we want to convert this into like an ISO founded date. So there's quite a few things which we would like to change before exposing that data to our consumers. And this is how it looks on the right-hand side here. So this is the schema of the data which we would like to expose. So as I said, it has different names, different types, let's say for the status and the registration date, and also it has a subset of the data, right? So not all the address attributes, for instance, are exposed. So how do we get from left to right? Well, we would use Apache Flink. We would use the Flink CDC project, which is based on Debezium, which takes it and integrates it into Flink jobs. Then we will have a Flink SQL job, which transforms the data from the first representation into the other. We'll see about that in a minute. And then we would use the Flink Kafka Sync connector, which takes the those processed events and puts them into a Kafka topic to which then our consumers could subscribe. So that's the basic idea. Now let's dive a bit more into how we do it. Well, in Flink SQL we think about it in terms of tables. So we have this customers table, and now this uses this Postgres CDC connector. So this is the log-based CDC connector, again based on Debezium, which goes to our database. So it uses like the credentials, database name, table name, and so on. And now whenever there is a change in that Postgres table, insert, update, delete, it will be reflected in this Flink table. So whenever we go to this table, this always has the latest state of our external Postgres table. So that's it on the source side, so our Flink Postgres CDC connector. On the sink side, I'm using this Kafka sink. And here you see already I do some changes, right? So like the column, the field names, they are different. So on my public schema, I use first name and last name rather than F name and L name. I also do, for instance, change like this registration date. So it has a different type. You will see how we go on converting it. So that's my sink connector. Now just having those two tables is not enough here, right? I need also to actually have a Flink job which takes the data from that table and puts it into that table. And this is how we would do it using Flink SQL. So it's a basic SQL statement. So we have a select, and we select our subset of data. So the data which we don't want to expose, we just don't select it. And then, for instance, for those conversions, well, I could call my function to format a date, or for converting this int status into text-based new, I could use like this case snippet to do that conversion. And then I do an insert into my Kafka-based sink table. So I select my data, insert it into the sink table, and now this will be running incrementally, continuously. Change happens in the source database, it will be captured, it will be inserted into the source table. This Flink SQL job will take it from there and put it into our sink table, which then maps to our public Kafka topic. And consumers could go to the Kafka. There's more I could do. I could add variables for doing some filtering. So maybe I have some test data or some private data which I don't want to expose. So I could just add a variables for excluding this data. Or I could add like derived fields. Maybe I would like to have the full name. So I could just use again with Flink SQL a bit of string concatenation to also make this derived name. So then let's, I mean, this shows like the basic example, right? So I use Flink SQL for publishing this consciously designed event to the outside world. So let's say I want to address this granularity concern. So maybe our model looks like this, so that a customer can actually have multiple phone numbers. So in the relational database, maybe the way we would model this is we would have a one-to-n relationship between the two tables, for IQ relationship from the phone numbers table to our customers table. And now in our public contract, we don't want to expose those row level events for phone numbers, right? We always want to expose change events which represent an entire customer. And now the nice thing of using Flink and Flink SQL is that this has a very expressive type model. So I can have things like an array of strings, or it could even be an array of another complex type. And I would like to expose this sort of data structure. So if I serialize this into a JSON for the sake of the example, this is what it would look like. So I have an array of all the phone numbers of my customer, and my consumers, they don't get those row level events for phone numbers. How do I get there? Well, again, I would use Flink SQL, and now, actually, as of Flink 1.20, this is becoming it's supported out of the box because I have this array egg function, which is coming with Flink SQL now. And this essentially, takes a range of values, as in our case, coming from our 1 to n join. So it takes those n values and emits them as an array. So we have this array egg function, which would give us exactly that. Now, if you are before Flink 1.20, you actually can implement this relatively easily yourself, because you can extend Flink SQL. You can have user-defined functions. Now, I don't have the time to show you how to do this UDF, but you can go to our YouTube channel and take a look there, because I did a video where I explained how to implement such an array UDF yourself. All right, let me skip over this, it's too important. I want to talk a bit more about schema changes, because I mean, nothing is as constant as change, right? It always happens. We have modeled our data, and now its schema is going to change, right? And the question is, how can we go and do that? Now, the first thing there to keep in mind is we need to evolve this schema with what's called forward compatibility in mind in the terminologies of Kafka and schema registry. So essentially what this means is if you have a consumer of your data which has the previous version of the data schema, it should be able to also interpret events which happened after this schema change. So essentially this means you can add new fields, because well, if a producer has the old schema of the data, which doesn't contain that new field, well, it will just ignore that field, which it doesn't know about, right? But the consumer won't be broken by the new event. Similarly, if we drop an optional field, that's also fine, because our consumer, well, it already knew this field is optional, so it needs to be ready to handle events which don't contain that field. So removing optional fields, that's also fine. But what we cannot do is, for instance, remove non-optional fields, because then a consumer which has the old version of the schema, it would expect this field to be present, and it would break then if we send a message which doesn't contain the field. So that's what's called forward compatibility, and this is how you should evolve those schema changes, because, well, we want to be able to evolve the schema as from the perspective of the data producer, right? So we don't want to be forced to synchronize upfront with the data consumers and have to do a coordinated process about schema changes. It would be a bit too much hassle. Okay, so to give you one example of what we could do, well, let's say we want to rename a column. So let's say we have this first name thing there, and now in our Intel data model, this used to be named fname. Whereas in our public schema, we already did like a good job from the beginning, so there it's called first name. But now we also want to clean up our internal data model and also change this from fname to first name in our internal data schema. And now the question is, how can we go and implement this change? And this is what would happen in terms of Flink in SQL. So you would first of all stop this job, so this insert into a job, you would stop it with what's called a save point. So if you were at Thomas' representation before, he's working about save points, which means we stop the job and it keeps track of the current state of how far it was processed. Then we would go to our source database and we would modify our schema name. So we would do the author table to rename the column in our source table. Next step then is, well, in our Flink job, we would actually add this field. So we would have both old and new name in the definition of this Flink source table. And finally, we would configure Flink to then start from this save point. And this allows us to then actually go and modify our insert statement, to propagate either the old name or the new name of the column, depending on, what kind of event do we get, right? So was it from before the schema change in the database or after? So we would use the coalesce function and propagate whichever value of those is non-null. And that way, we would have completely isolated our consumer from the change to the schema in our database, right? Because in the public stream, it always was named first name, and then we did this internal refactoring of the data model, well, it wouldn't impact our consumers. That's just a basic example. There's many more things which you could do. It can also be much more complex, but this should give you an idea of how you can go about implementing schema changes. And now what I also want to say is, well, this needs to happen in quite a defined and delicate order, right? So we first need to change our schema in the database, then in the Flink job, and all this is the reason why I'm saying, okay, this Flink job, which exposes our data contract, this also should be owned and managed, maintained by the team which owns this database and its schema, right? So they should manage all those things together and make this sort of a data problem. So we don't want to have like another team which then works on this Flink job because then you would be back to this notion of like having different teams working on the same thing and having to coordinate. So it should be a single team which owns and which is responsible for this entire process. All right, so let me wrap up just to recap what we have learned. Well, first of all, we have learned about those tools, right? Flink for stream processing, Debezium for log-based change data capture. And now using those tools together, it helps us to address those concerns, right? So as you have seen, well, using Flink and Flink SQL, we can encapsulate our internal data model, right? So if you do changes to the schema of our internal data model, it doesn't affect our consumers. So we have addressed those concerns. We have spoken about like denormalizing the data, like taking care of the granularity, something we can address. We have spoken about the exposure of all our data. So again, using some variables, we can also implement that concern. So I would say, you know, with Flink, we can take those change-based streams and pretty much get on top of that situation. So coming back to our question, do we have a problem or not? Well, I would say, as I mentioned, it depends a little bit on the context and how we use those events. But if you do think it is a problem and CDC would break an encapsulation, well, we have the tools and the techniques for managing that situation. And the final thought I want to send you home with is, well, with those tools, Debezium for log-based CDC, Flink for stream processing, they give us the means to reason about our data in all the different terms or stages of the data lifecycle. Because what's interesting is if you look at individual changes, like the update to a specific purchase order or the insertion event of a specific customer, those events they have very high value right now at the current time. So let's say I have events which describe the purchase order, you know, and I need to send them out to some other shipment system. Well, I need to handle those events like today, right? Otherwise, I don't know, my shipment would be delayed. So I need to act on the data quick. Whereas if I go to like next month, well, I don't care about the change events from 4 weeks ago, right? From individual purchase orders. So individual events, they have a very high value right now, and then this value goes down over time. Whereas if I look at the entirety of my change events, like all the purchase orders or all the customers, well, this aggregated value, this goes up all the time, right? Because I don't know, I could do analytics on this data and get insight into like customers who ordered that product, they also ordered this other product. So the value of all my data is aggregated data, this goes up all the time. And those tools, Debezium and Flink, they help me with reason about my data on either side. Finally, a few links. So if you want to read more about this in the written form, the blog post which describes this. There's an example repo which has like all the source code we've seen, so you can also play with this by yourself. And finally, I'm very happy to engage with these. So you can reach out to me via email. You can go to my blog. You can go to Blue Sky if you like. And that's all I had for you. Thank you so much, and have a wonderful rest of the conference.
Thank you very much, Mr. Jamal. Very interesting presentation. Thank you. So you have back to your sitting.